a real-world problem with some bogus assumptions, but that's not the objective here. I just want to show you a specific spatial analysis to select wells. So I'm going to go over the objective here. We are going to identify wells of high water quality in Ingham County. Some groundwater wells are susceptible to contamination from polluting facilities or low quality surface water. Our objective is to identify wells of the best drinking water quality. That is, wells that are surrounded by natural multi-barrier zones, located in pollution-resistant aquifers, and located far away from hazardous and toxic waste facilities. So the whole analysis is going to, it can be divided into 3 stages. Well, first of all, we are going to use all the wells in Ingham County, and we have to select a specific subset that meets 3 criteria. First of all, we want active wells, wells that are in use right now. Second of all, we want wells that are relatively deep. If you recall from previous demonstration, shallow wells are more prone to pollution from surface water, and therefore deeper wells, on the other hand, are more likely to be to have cleaner water. And finally, wells, the best wells should be in rock aquifers. That's because these types of aquifers also are not, it's not easy for water to seep through it, and therefore some pollution can stay within the aquifer and not get to the well itself. So that's going to be our subset of all the wells in Ingham County. Then we are going to focus on pollution, potential pollution sources. First of all, we will look into pollution from toxic facilities, or TRIs, and hazardous waste facilities. And then we will also evaluate low quality surface water. That all is going to be combined into one big potential pollution area, and we will remove cells that fall within that area. Finally, we are going to look at natural protection. That is, we will build another large zone that will combine wetlands and wellhead protection areas. Wellhead protection areas are essentially regulated areas that that have an objective of protecting water, drinking water from wells. Wetlands, on the other hand, behave like sponges. In other words, water in wetlands stays for a while, is stagnant, and whatever pollution comes from rainfall or surface water can then be retained in wetlands, and whatever seeps through wetlands is also potentially cleaner water. So from waters that were excluded through pollution, we're going to have a subset of wells that then we are going to evaluate within the natural protection areas, and these wells, we will treat these wells as wells that are of best quality drinking water. All right, so I'm now going to move to our study area, which is Ingham County. We have a variety of different data sets here that I'm showing you. The data sets are obviously the boundary of Ingham County, the hazardous waste facilities, the TRI facilities in Ingham County, the roads, which we are not going to use for analysis, but they just show you the big picture. And then we have water wells, which we have to clip because they are for a larger area. We have water bodies below quality standards. These are those water bodies that could be contaminated, so we have to exclude them as areas for better water quality in wells. And then we will have those two protection zones, which are wellhead protection areas and wetland inventory. Wetland inventory, or essentially wetlands in Ingham County. Throughout the analysis, we're going to produce a lot of data sets that are going to be intermediate. So I'm going to periodically remove them for clarity. So just to be clear, we are not going to keep everything that is produced, because I assure you there's going to be probably about 20 different data sets being produced, so we would get lost pretty easily. So let's start from removing roads, because they will not be necessary for our analysis. I'm going to keep the background. I like to have it because it shows general picture. You see where the major roads are, you see where the specific towns and cities are. So this is going to be kept. And at the beginning, we have to start from getting the wells, obviously. Oh, and by the way, I will also turn off the data sets that we are not going to use right now. So as you can see, there is a much larger area of wells that is being provided, and now we have to clip the wells so that they are within Ingham County. So we have this geoprocessing pane, and it's very easy to find the proper tool. Here you have the clip tool, and the input features are our water wells. The clip features going to Ingham County boundary, and then I also created or listed some names for the data sets that will make it easier then to understand what we see, because usually GIS gives you some sort of a generic name, but those names are not very informative. So what we are going to name this is clipped wells. And then let's run it. You can see that every single tool has some sort of information about whether the tool, the operation was successful, and then you can look into details. There are some messages here, and so forth. I'm not going to look into that because it's not essential. Another thing to point out is that ArcGIS Pro keeps the same symbology for the output as symbology for input. So that's why you don't really see Ingham County wells, because the symbology is the same as for those wells within the larger area. But I can easily show you that we have our subset by turning off those water wells in selected counties. Since we are not going to use it, I'm going to remove it. As I said, we're going to remove as many data sets as possible to see essentially what's happening. Okay, so as I said, the wells have to have specific conditions. They have to be in use, they have to be relatively deep, and they have to be within rock aquifers. So we have to now make a selection, and that could be done in two ways. First of all, we could use select by attributes and then export that dataset. But that requires two steps. ArcGIS comes with a tool that's going to combine these two steps together. This tool is not surprisingly called Select. And we are going to, obviously we have to build a query here. So selection essentially, so it's similar to select by attributes, but also give a name for our output. So the input features are obviously the clipped wells. I want to name these output as wells because these are going to be our major wells which we are going to work with. And then we have three conditions. I just want to make it larger so that you can see those conditions. So the first one is that they are active, which means this is well status, and you have here active, ACT stands for active, and is equal to obviously. The next one is that they have to be within rock aquifers. So that's AQ type is equal to rock. And finally, the depth, we are going to have well depth greater than, and I just selected value of 100 here, and it's just a made-up value. One thing to note is that I use AND as a Boolean operator, and that's because all three conditions must be met. So let's run it. And since again we have the same symbology, we need to turn off the input. So as you can see, some of the wells were excluded. We don't need clipped wells anymore, so I'm going to remove them as well. Okay, let's keep wells for now turned off, because now we are going to move to our potential areas of pollution, and these are going to come from hazardous waste facilities, TRI facilities, and water bodies below low quality standards. So let's start from hazardous waste facilities, which are going to be these circles. And then how do you establish an area that can be affected by this type of waste? Well, you can simply build a buffer around it, because obviously these facilities in terms of groundwater may have a larger effect than, for example, air. So for that we will use buffer. As a tool, and I was very generous here, and assume that the the effect of those facilities may be up to 1 mile. This is a very large area, but it nicely shows then the following or the next stages of this analysis. So that's why I made it so large. So our input now are hazardous waste facilities. I'm going to call it hazard zones. All right. And then the distance is going to be 1 mile. Let's check if everything is right. Yes. And now you can see those buffers around those facilities. They are nicely transparent, so you can see if they overlap. You can see that overlap. We will repeat the same for the toxic release inventory facilities. So we can reuse the same tool. Obviously, the name has to be different because we are working with a different data set. And then let's, again, 1 mile, let's run it. And I'm going to do some changes in symbology here. So first of all, I want to show you those facilities, but second of all, ArcGIS used here a default coloring, which means that you have the same color for both buffers, both types of buffers. So I'm just going to change the color to let's see, to maybe red, and I need to also make it transparent. So now you can see both types of buffers. And okay, what do we do next? All right, next we are going to, before I continue, I just want to show you something interesting. So the attribute table of your buffers is essentially the same attributes as your input facilities. So for example, if you open the TRI attribute table, you can see that there are the same attributes, except for obviously the shape, and then there is buffer here. I want to explain that buffer because that is interesting. The buffer is not, well, we decided we are going to have 1 mile, right? But we have here a different value. It's not 1 mile, and that value comes from projection. This particular data set uses projection where units are meters. So when the buffer is calculated, the distance is going to be recalculated to meters. So that was sort of an interesting well, kind of factoid. So what I'm going to do now is I'm going to focus on overlay operations, essentially because, as I mentioned during the lecture, they create quite different attribute tables. But because the attribute tables are going to grow with intersect or union, because that's what I'm going to do, I want to reduce the size of the initial attribute tables of the inputs. So we are going to use the TRI zones and hazard zones. So as you can see, there is a bunch of attributes here. So I'm going to remove most of them so that the output is going to be clean and easier to interpret. So the only thing I'm going to keep is site specification, and the rest is going to be deleted. Those two cannot be changed, they are fixed. Also, you cannot delete shape, length, and area. You can recalculate that, but you cannot delete that. I will show you, see, you can't delete this attribute, but we can delete origin, feature ID, and we can delete county and buffer distance. And therefore we are going to just have a specific attribute for this specific hazard zone feature class as unique for that particular feature class. I'm going to repeat the same for TRI zones. So we are going to just keep facility name and remove zip code, whether it's carcinogous or not, and then buffer distance, and then ID of the origin, which were our points. And that means that the only thing from this particular buffers feature class that is unique is going to be facility name. I can actually make it a little louder. So now we have two attributes that I want you to focus on when we are going to do intersect and union. So let's start from intersect. Simply because it produces a much easier to interpret attribute table. So we are intersecting the TRI zones with the hazard zones, and we are going to keep all attributes. So nothing else is going to be changed except for the name, because again I don't like the default. So facility pollution zones. That's going to be my name. And that's essentially everything I need to run intersect. So let's now change the color again, because it's going to help us to see the intersection. Luckily this time it automatically set transparency. I don't understand why it does sometimes and it doesn't in other cases. And let's open the attribute table of our intersect. So as you can see in our attribute table, we obviously have all the attributes that come from both inputs. So we do have the site specification, and we also do have facility name, right? There is a couple more attributes which are simply feature IDs of inputs. So you have object ID, which is also feature ID, and that's also is going to be in the output. So I I want it to be as simple as possible. So I'm going to remove them because they are not necessary. They do not provide us with any important information. And now you can see that we have, for each of those intersect polygons, we have a value. We have 10 TRI zones and 6 hazard zones, and but we have only 11 intersects, and that's because intersect is essentially only area which where both of those inputs overlap. So if you're going to, I don't know why I have this open. So if you're going to just look into the intersect, as you can see, these are areas where we have an overlap of inputs, right? Look into TRI zones or hazard zones. So I want to point out to a couple of things, actually to one thing. In most cases you have just one polygon, but in here you have multiple overlapping polygons. And that's because if you look into buffers, and that's I think from hazards or TRI, well, actually in both cases you will see that in the initial buffers already overlap. So then when you create an intersect, you're going to have actually polygons that overlap for the same feature class. I will try to show you what I mean. Let me check. I just want to make sure I have the... Oh, I know. So I'm going to again go back to the attribute table and focus on those specific intersect areas where you have two polygons that overlap. So that's going to be, I think, this one and this one. No, this one and this one. Okay, so you can see that if I highlight 10 or 11, I still have the same geometry. And that's because initially we had multiple overlapping buffers. All right, so that's the intersect. Now I'm going to move to union. And use the same, obviously the same inputs, and keep all the feature class attributes. And now what can we see? Well, we have to open the attribute table because that's what I wanted to show you. Again, we have the hazard zone of feature IDs, and you can see that for some we have -1. That means that this particular area does not exist in one of those inputs. So for example, if you look at this highlighted portion, we do have hazard zone, but we don't have TRI zone. It's just that portion of the whole union that belongs only to one of the inputs. Maybe another one. I have to zoom in slightly. That's probably easier to see. So again, it has a value -1 because it doesn't belong to TRI zone, but it belongs to hazard zone. If you don't believe me, I can highlight hazard zone and turn off this one, and you can easily see that it is within hazard zone, but it is not within facility pollution zone. So that's one thing, right? Those minus ones means that we don't have feature ID for areas where we don't have intersection. But I would like to show you also those specific attributes that come from inputs that I mentioned, which were facility name for TRI zones and then site specification for hazard zones. Actually, I should have renamed that, but that's okay. So this is our union, and now what happened here? Why do we have empty space here? It's pretty straightforward to understand. All of the attributes are copied from both inputs, right? That's why we have both facility name and site specification in our union. However, for areas where there is no intersection, only one of those two attributes is going to have a value. That is an attribute that comes from that complement to intersect. So let me focus on just this one. Doesn't really matter. Actually, it does matter because I want you to see where this thing is. Oh, we can't see it because... all right. So as you can see, this particular I don't even know, this particular polygon belongs to TRI zone, right? And therefore it's going to have site specification value. Actually, wait a minute. I messed up because yeah, the color is the same, so let's focus now on facility pollution. Is going to be easier. So those kind of greenish areas are intersect areas, and then those areas outside are areas that belong to one of those inputs but not both. So now I'm going to go back to my union, and here you have that feature ID that I highlighted. So that feature ID is I'm sorry, I should have had this on, right? So this is the one that is on. I messed up the selection of what's displayed, and that's why I am actually confused at this point. So now we have the correct datasets displayed, meaning hazard zone, because what I want to focus on is this particular polygon. So I need hazard zones and I need the union. All right, let's go back to hazard zones. We have site specification, I don't need that, that's just annoying. And you can see that it actually has a value for site specification, but it doesn't have a value for facility name, simply because it doesn't belong to the intersect of both inputs, and therefore there is no facility name for this particular piece, right? It's just outside of the area, that's why it's empty. This is the most important difference between union and intersect in terms of attributes, that in union you're going to have empty space for areas that are outside of the intersection of the both inputs. So I just want to show you the attribute that actually is an intersection. See, here you have an intersection, and that means that all of those input attributes have some value, because obviously they come from two attribute tables where each of them for their respective attributes have a value. Okay, so this is the intersect and union. Since I'm going to use union for my analysis, I will rename it. All right, it doesn't really matter. I just don't like the name of it, so I'm going to rename it to total pollution. Okay, maybe not total pollution, but total facility pollution, because this is pollution from facilities only. It's just for the sake of okay, facility pollution zones. Oh, that was the intersect. All right, so total facility pollution is our union, facility pollution zones are our intersect. Okay, see, these are the intersect areas. So I'm not going to work with intersect anymore, so I want to remove that for clarity. We need those total facility pollution for further analysis. So these are this is the extent of pollution that just comes from facilities. The next step is to add to it water bodies below quality standards. So what I'm going to create is I'm going to create a zone that is going to have both facility pollution zones and those water bodies that we can call them, for simplicity, with low quality water. All right, how to do that? Well, in this case, we have to use a tool called merge. For now, we are not going to worry about the attributes. We're going to clean that stuff later. So this is our current input, and then these are the water bodies, and we want to have one dataset that has both. So that's a tool that I didn't talk about in class, but it has a very straightforward objective. Is very straightforward. You just have to input both data sets that you want to use here. That's going to be water bodies below quality standards, and then total facility pollution. And we are going to call it, how did I call it? Pollution zone. All right, because it's just the final pollution zone, so let's just call it pollution zone. Now you can see that there's a lot of different fields here. Now, what do I want to do with that? Let me think. Yeah, I'm going to just keep that. So these are all the fields that come from those two data sets. To be honest with you, I didn't test that on attributes. So let's see what we're going to end up with. All right, we are going to end up with the correct data set. If you look at that, that is our pollution zone. And then let's look. I'm going to zoom out a little bit so you can see that. Let's turn off the water bodies, okay, because it has the same color. Maybe let's change the color so you're not going to be confused with water bodies. Yeah, my selection is a little bit not very interesting, but whatever. Okay, so now you can see that those water bodies were added to those facility buffers. But what I am interested in is the attribute table, because to be honest, as I said, I have not tested that. So it's nothing really surprising here. And that's actually within the hair area, so it's not the best choice, because these overlap. Maybe I'm just going to select something like this one. No, I don't want, I want to select it. And let's look into that. So you have here null value. Null value means there's no value, and that is not surprising because this is a lake or pond that doesn't have values for our buffers, right? Facility name, TRI zone, all of that is not here. That's why it's empty. And you also see that there's tons of different attributes. That's because now we combined those areas or those attributes from our facility buffers with those lakes / rivers. So what I want to do, just to kind of make it simpler, is to dissolve all of that into one polygon. I don't think I'm going to need any of those features, therefore I will simply dissolve it. The problem here, if I want to have one data set with just one feature, right? That's what I want to have. I want all of those, I don't know, like purple areas as one big polygon. So I will use dissolve. But for dissolve, if you want not to have like dissolve in different pieces, but just one big feature, you have to have, as I said in class, you have to have an attribute that will have the same value for all of the current features that we have here, for all of the 194 features. We don't have anything like that. As you can see, every single input except for polygon except for polygon has multiple values, but we cannot use shape. So what I'm going to do is I'm going to fake it, and I'm going to add a new attribute. I don't know. Oh, well, it opened here, doesn't matter. Which is going to be a completely fake, meaning the only reason I'm doing it is um, I am too I'm not I'm not very patient. So here you have this new attribute which is fake just for the sake of dissolve. I have to calculate something here, so I just pick whatever. It's a number. It has to be a number, so just pick one. Okay. Again, it doesn't matter. The only thing that matters here is that now I have an attribute that allows me to dissolve all of those 194 features into one. So to do that, I have to now look into dissolve. And I'm going to dissolve pollution zone. How do I call that? Well, I wasn't very creative here and I called it pollution zones. You can, well, you could, I run out of creativity with names. And you have to select the dissolve field. Now this is temp. And we are going to create multi-part features, meaning that there's going to be just one feature but with multiple polygons, so to speak. So let's run it. And let's look into, so as I said, I wasn't very creative with the name. You can see that we have this new oh, we need to close that. We have this new dissolved area. What is this area? This area is essentially all of the potential pollution sources. And again, it's complicated because of the fact that the color is the same as the input. So I changed the color to something more, well, I don't know whether it's better, but something less different, right? And by the way, I want to show you the table for pollution zones. And as you can see, we have only one record. So this is one feature, but it's composed of multiple polygons. That's what it is, okay? Now I have my pollution area. That's the area where I want to now identify wells that fall within that area, because those wells have a potential to be contaminated from those different sources. But I'm actually interested in wells that are outside of that zone, right? So let's go back to wells. And so you can see that some of those wells are within the pollution zones, right? And then some are outside. Those that are outside are protected from contamination. So now I need to use a tool that allows me to get rid of those wells that are within our pollution zones. And this is another tool that I didn't talk about. It's called erase. But it's again very straightforward to understand. What I'm going to do is my input feature features are going to be wells, and then the pollution zones are the areas which I'm going to use to erase my wells. You have information here. the features that will be used to erase coincident features in the input. Okay, so that means I will select pollution zones, and then I have a name here, because whatever is outside are the potential areas for high quality drinking water. I'm going to just call them potential wells. Okay, I have really bad eyesight, so it takes me a while to type names. I just want to double check that the name is what I selected. Okay, so now let's run it. And the unfortunate color. There you go. See, we don't have wells that are within our, well, there you go, within our pollution zones. Okay, if you are skeptical, let's change the color of, no, I want to change the color of my potential wells to something different. Let's say green, and then we have wells. Why don't they show potential wells, and then pollution zones? I mean, I'm a little confused with my colors, because it seems like all of the wells and the potential wells should not be the same thing. Okay, let's see. We have 7,000, and then in here, let's just check, because I am a little confused. Pollution zones and wells, right? So wells, and the output were potential wells, so that is wells, and then potential wells. Yeah, there is a bug in ArcGIS. You can see that wells, there's obviously more of them, because some of them fall within the pollution zones, right? And actually, no, it's not a bug, it's me. It's going to show up because I erased them. So that's why you can't see them. Okay. No, it's still the same problem. See, I don't see the wells that are within the initial zones. Well, that is a matter of display, which is not my fault. But if you look at the table, everything seems correct, at least, because there's obviously more wells originally than wells that are after erase, right? There's less of them. So that means that the procedure of the tool works properly, but it just doesn't show properly the result. Or does it? Okay, that was probably the zoom problem. So everything's fine. So just to sum up, you can see the initial wells, some of them fall within the pollution zones, and then after that, those that only those that are outside pollution zones are remaining. All right, so we have now wells outside of pollution zones, but we also want to add areas that protect wells from potential pollution. So that would be wetlands, and then the wellhead zones. Let's see, because again I just want to get rid of stuff that may be annoying and unnecessary. What is unnecessary here? I just want to have the wells that are remaining. And now I will work with my wetland inventory and wellhead protection. So what am I going to do? After I process these two data sets, I am going to keep only those wells that are within those zones, because those zones allow me to protect the wells from potential contamination that comes from a variety of sources. So that is my objective. That's going to be my final output. So how do we do that? Well, it's actually pretty easy. You don't really have to do much. You can use union. If you want to, make it beautiful in a beautiful format, you can always get rid of attribute and then dissolve, but that's really unnecessary. It's only a matter of intersection, and to do intersection I have to first combine those two zones, wetlands and wellhead protection areas. So I'm going to do that using union. And now we are not working with wells anymore, only those that are remaining. So the union is going to be our wetland inventory and our wellhead protection. And because we are going to have areas of protection, let's just call them protection zones. All right. Okay, let's run it. You can see now that I have one big area with that combined those two data sets. Here, however, you can see again we have tons of different attributes. Here, however, I need to do dissolve. Why do I want to do that? I'm going to show you something to maybe sell you on the reason to do that, because it's actually not seen easily. So, and let's zoom in. So right now, because we used union, all of that, we have all of the polygons, intersect, whatever's outside of intersect, for both of those data sets. And that's a mess, and that may cause some problems when we intersect this with our remaining wells. So what I'm going to do is I'm going to create again one attribute that will have the same value and therefore can be used to dissolve. I don't really need anything new here because it doesn't matter. I'm not going to focus on any of the attributes of these areas. I just need the geometry. So let's keep any of them. Is this a number? Just want to make sure it's a number or not. All right, I don't really know whether it's a number or not, but what I know is that the feature ID is a number. So I'm going to calculate a uniform value. And then I can use dissolve. All right, and my input features are going to be protection zones. No, protection zones. Protection zones. And then, oh my gosh, protection zones. I mean, seriously, I have no idea. So let's call it protection areas, right? Protection area, because it's one. Protection. Okay. Area. And then the dissolve field is going to be this field that I just sort of recalculated to 1. And let's run it. And now we have one big protection area, right? There's just one big feature. Oh, well, we are almost done. So these are the wells that we are interested in. This is the area that is going to protect those wells. I'm going to add transparency to it, and then maybe change a little bit my wells, maybe make them larger. Okay, and I don't like the color, so let's make them pink. So if you look at this, now I want only the wells that are within those protection areas. There is a very cool tool to do that. It's called Intersect, right? So now we are going to use Intersect. And that's actually what's called point in polygon intersect, point in polygon operation. It's a very common operation. So my input features are, what are those? Potential wells? Was that the name of it? Okay, just want to make sure. Yeah, potential wells. So that's the points. And the area is protection area. And let's say final wells. Okay, now let's see. I don't need attributes to join. I'm just going to take feature IDs because it's just gonna make a lot of mess and it doesn't matter for me. Oh, maybe actually no. Let's see what's going to be remaining. And final wells. Okay, let's run it and change the color, of course. Oh, actually I can turn that off. You can see, right? Whatever's remaining falls within those protection areas. We can check how many of these are. I don't know. Didn't I open the table? Attribute table. Oh, and it's correct because I did that before. It's 693 wells. To summarize, those wells are deep wells within rock aquifers still in use, outside of buffers around toxic facilities, outside of water that is of lower quality, within wetlands and within the wellhead protection areas. That is what we have here. So with that, I want to finish, and this is the whole analysis.